Hello students, you are welcome to another wonderful section in mathematics where we are going to be discussing the different parts of a right angle triangle, just like the one I have on the board here. So we are going to look at how to identify the different sides of a triangle with the names hypotenuse, adjacent, and opposite. Now, this is a right angle triangle on the board here. Let me rub this off. To save time, I'm already having the diagram on the board. Now, how do we recognize that this triangle is a right angle triangle? Is by looking for a small square box. The angle represented by the small square box is 90 degrees. That's a right angle. So a right angle triangle is a triangle that has one of its angle 90 degrees, and that is the largest angle. 90 degrees is the largest angle in the right angle triangle. So angle ABC, you can see the way an angle is represented or written. So B in the middle with this symbol, showing that you are referring to angle B is 90 degrees in this case. Now, let us look at how to identify the other sides of a right angle triangle. As you can see, this one is already written. The side that is directly facing the 90 degree is the hypotenuse. It does not change. When I draw a line from here, the side it touches is the what? Hypotenuse. So AC is the hypotenuse, and it's going to remain the hypotenuse throughout this discussion, because that is where our 90 degree is. Now let's look at how to identify the adjacent and opposite. We cannot just pick any of the sides to be the adjacent or the opposite. There must be an angle of reference before we can identify the opposite to that angle of reference. Now let's keep this as alpha and this place as theta. So we are having two other angles now apart from the 90 degree, that is alpha and theta. As I said earlier, the remaining two we add up to give you what? 90. We say that they are complementary. So alpha plus theta is equal to 90. They are complementary. And when ABC, that angle alpha is correctly written and BAC, that's how it is correctly written. Then BCA becomes this angle theta here. So BAC plus BCA gives us 90 degrees, they are complementary, and this plus the whole of it gives us 180, which means the sum of angle in a triangle is 180 degrees. Now, back to the opposite and hypotenuse and how to identify them. We are going to have two cases. This case one. In this case one, we are going to be considering angle alpha, this alpha, then, and the side that is directly facing alpha, let me trace it out. The side, I draw a line from that, you can see, is touching side BC. That BC becomes the opposite to alpha. So opposite to alpha is BC, that's how to identify it. So, now, let's look at the what? The adjacent. What is the adjacent? Already the hypotenuse is fixed. It does not change. It is side facing the right angle. Now that we are able to identify the opposite to the side facing alpha, BC in this case, it means that the top side, the remaining top side, becomes the adjacent. In this case 1. So BC is opposite to alpha, AB is the adjacent, and the hypotenuse is what? AC. Hypotenuse is AC. Let us quickly consider another angle. Let's consider another angle. That is the remaining angle, that is the theta. So angle considered here now in case 2. That's case 2. Case 2. We have angle theta considered. Now let us look at the side. Can you get the side that is directly facing theta? Yes, you are right. The side AB is facing theta. And so that is our opposite to theta. AB is opposite to theta. Then the remaining side, BC, become the adjacent. So look at from this, which you are already used to. So you'll be hearing that. So we start for sine is going to opposite to the hypotenuse. In this case 1, our opposite is BC. BC is opposite to alpha, and AC is the hypotenuse, and cos alpha, that is the adjacent. The adjacent is AB divided by the hypotenuse AC. Tan alpha BC, which is the opposite, divided by the adjacent. Then we have our what? Theta considered here. Sin theta is equal to AB over AC, theta AB opposite, and over what? Over AC. The hypotenuse will remain the same thing. Cos theta BC, that is the adjacent, over hypotenuse. While tan theta AB over BC. AB over BC, 2 are opposite to the adjacent. AB over BC. So that is how to identify the size of a triangle. Another time, when you are asked where is the opposite to, where is the opposite and adjacent in the right angle triangle, maybe that is already drawn, you just need to ask them first, which of the angles are you considering? Which of the angles are you considering? Is it this or this? It is then you will be able to identify your opposite and your adjacent. With the knowledge of this topic, you will be able to solve problems from angle of elevation and depression without stress, because in that topic it's going to involve drawing right angle triangle in many cases. And so, take it very important and solve more problems from here. No, we have not solved any problem, but take it and work on it, try to solve problems. When we meet in our math class, we are going to be looking at how to apply this in solving problems. So before we go, we also have the inverse of this, the reciprocal of each of these angles we have mentioned. When we say sin alpha is equal to opposite over what? Okay, sin alpha, the reciprocal of sin alpha is, what is it called? 1 over cosec theta. So in our next class, we are going to be looking at how to apply this in solving problems. And possibly we go into solving problems in angle of elevation and depression. Have a nice time. I remain your educator in this platform. God bless you. We meet another time.